All right, we're going to do another dot structure. The dot structure we're going to be doing next is going to be for CH2O. Step 1 in drawing dot structures, again, is always to count your total valence electrons. So carbon is 4, each hydrogen is 1, so that's 2, and oxygen is 6. So we have a total of 12 electrons to work with. Step 2, I'm going to arrange my atoms. I'm going to put carbon in the middle. And then remember, we always try to get the atoms surrounding the central element. So I'm going to put an H on either side, and then to make it symmetrical, I might put my O on top or bottom.
Mommy, why are you talking to the computer?
I'm doing a dot structure example. So let's do step 3. Step 3, I'm going to add my lone pairs to my atoms. Hydrogen never gets lone pairs. If you notice, carbon is empty on top, so it gets a pair. And the oxygen gets a pair on the left, bottom, and right. Step 4, I count the electrons in my drawing. I have 2, 4, 6, 8, 10, 12, 14. 14. That's not equal to the original number, so we subtract to get a difference of 2 electrons, which means we have to add 1 bond.
Really?
So we have a couple places where we could add a bond. We could add it between the carbons and hydrogens, but hydrogen can't have a double bond because there are no lone pairs. So the only feasible location for adding a bond is between your carbon and oxygen because there are lone pairs. So I'm going to add, so I'm going to add my bond here. And then I'm going to go ahead and take away a pair of electrons from each atom that bond touches. So again, anytime you add a bond, you're going to take away a pair of electrons from each atom it touches. So my final structure is H single bonded to carbon, single bonded to H, double bonded to O, with lone pairs on your oxygen. There is your final dot structure.